Welcome to another video. We're gonna jump in where we left off. It was doing a downvote on this documentation. We can see there are plenty of errors in it. It's telling to set up a static route to a host address, not a network address. And not only that, it's saying that the next hop to this static route is in the same subnet that host address falls into. So why would you need to set up a static route to a route you already have in your route table as a directly connected route? That I really went over in the last video. So this video, let's move on and hopefully we can get a sense of what it was actually telling us to do and get that to work. So router B, here's a verification step where it says show route. And this I pointed out in the last video as well. You would never see a host address in the route table. So it's clear that the graphic here, it did not come from a networking device. It was just a template that somebody went in and edited. But let's see what kind of routes are in the routing table. And maybe there's one that looks like it could be what they were getting at. So yeah, so here's directly connected route in the routing table. So it looks like they want a, so they want the, any route from protocol BGP, they want to be exported. What? So it looks like they're doing a export policy for the static route, but yeah, this I don't think makes sense either. So this is a little bit more pedantic than this. This is obviously, I mean, this is saying like the first step in serving a bowl of ice cream to someone is to take the peel off and use a straw to open a front door. It makes no sense at all. But here, it kind of makes a little bit more sense that you're trying to redistribute a route into the BGP protocol that is not normally in the BGP protocol. But I don't know how you could, because here you can see we're exporting. So from protocol BGP, we're going to apply this to protocols BGP. So why would you export a route from BGP back into BGP, especially if you don't have more than one BGP group set up? Like, I understand if you would have multiple BGP groups, but you can see in the configuration, there's only one BGP group. So this is just as nonsensical as this one. I'll kind of not vote it yet until I kind of figure out more what to say instead of just the Jackie Chan meme. But here we'll kind of just power through and get through the whole thing, and maybe it'll make sense, even though every step along the way kind of doesn't make sense. Maybe after I finish the whole exercise, it'll kind of make sense more what they were getting at, and I might be able to then go and fix the mistakes in this document, downvote, and send that over to the friendly folks at Juniper who love my submissions. So let's see here. Set, so edit, policy, options, policy statement, AS prepender, set from neighbor 198.51.100.2, set then AS path prepend 65555, and we're going to apply this policy edit protocols, BGP group P1, set export, prepender, commit. This is on router B. So the next command is going to be a verification command on router A. Oops, and don't need to run because I'm not in privilege mode. Or I'm not in configuration mode, rather. So of course I don't see this route in there. There is no. So it looks like they're trying to advertise this route into BGP, but you wouldn't do that with a static route. You would do that by having this route be exported or imported into the BGP protocol from some other protocol, such as being directly connected. So I don't understand why they're saying to do that. Let's see if I have this command. Oh, there it is. So here's the description. Enforce first AS in AS path is the neighbor's AS. So set protocols, BGP, enforce first AS. And this is one of those things where it's really specific. I doubt it will be on the exam, but it's just kind of a good exercise, especially to kind of solidify my understanding of what I'm going to see just on a networking device. So now it says when you check the route again, you will see the route, the host address no longer getting through on router 8. Well, you're not going to see that in the beginning because it's a host address, not a network address, but just move on and hopefully it'll make sense as I get to the end. So show BGP summary. And everything looks good there. I've got 2 established connections. See if there's a detail so I can see the actual state. We've got summary, we've got neighbor. Let's see if I can just look at all the neighbors. I can. I get a lot of information here. I can see state established, which I'm sure in the summary, show BGP summary, as long as you have information here, especially last up, down, you can just assume it's in state established. But let's keep going. So now, so the first line shows the number of groups configured and the number of peers that are up or down. This output shows there are 2 peers, 192.0.2.1 and 198.51.100.2 up. Sure enough. The table portion shows that there are no paths in the inet.0 table. So we got a table portion. We do, yes. So here's inet.0. Yep, there's nothing in there, 0. We can see that router B has 2 peers, autonomous system 65541 and 65543. Sure enough. When the state column shows 3 numbers separated by slashes, the BGP session is up. Oh, okay, so here we go. It looks like we've got 4 numbers separated by slashes. I mean, that might be worth a downvote. I mean, we do have 3 numbers separated by slashes. We have these 3 numbers, these 3 numbers. We also have, so we have multiple combinations of 3 numbers separated by 3 slashes, but that's just because we've got 4. So I don't think that's worth a downvote. It's just one of those things that in light of these sort of things kind of makes me wish I was a good enough video editor to just edit in the Jackie Chan meme. So moving on. The next verification command is on router C. It's show BGP neighbor. And we've got established. Looks good there. Let's take a look at the show BGP summary on router B. So everything looks good. That's actually the command we looked at earlier. So I'm not sure why I want you to look at that again. Now we're going to do show route to protocol. Oops. Do that from outside of configuration mode. So it's missing that route. So with the show neighbor command, you can see the export policy by name. Okay, so let's look at that. For BGP neighbor, so the export policy, we know that's going to be, let's see here, configuration, pipe display set, pipe no more. So it's going to be export static. Let's see if we can see that. Here we go. So here's the export policy, export static. Now with the show BGP summary command, you can see there is now one route in the inet.0 table. So we can see that very clearly did not happen. It did not put the third subnet in that /29 stack in the table. You can see the first subnet in the stack is there, but this .17 falls into the third because for /29 it's going to be every 8. So it's going to be 0 through 7, 8 through 15, and 16 through 23. And this is going to fall into the 16 through 23 subnet, which is the third one. But we can see it's not in there, so let's do some troubleshooting and see if we can figure out how to get that address to show up in this table like this. So it might not be the way that it's expected to in following this exactly, but if it shows up in that table, I think I'd consider that a success. So especially if we can get the AS path and everything to match. So we're going to need to put this into BGP. So let's go ahead and do a look at the configuration again. So we can see that route actually does not exist on this device at all. We can see the only way that route is configured on this device, following with the documentation, is part of this static route. But I don't think there's a way to, well, let's take a look at that re-advertise knob some more. So the other thing we can do is maybe set this next hop to .20 as it was in the documentation. Maybe that is a correct thing. I just don't understand why you would have a next hop be in the same subnet, because that analogy I made before, where if you're in a house, you have somebody in your house and you have two ways to leave your house, door A and door B, and the person in your house says, I need to leave and go home to my house, which is house C. You say, oh, well, sorry, I only have the door to A and the door to B. But if you go through the door to A, the person at A can tell you how to get to C. So that's my understanding of how a static route will work. You've got to have that next hop value be something that you know about in your routing table. And it has to be different than the destination that person wants to get to. So clearly this route that they give is a violation of that kind of understanding, but I'm always open to having my understanding challenged and hopefully improved. But we'll see if this is even something that's able to be accepted. And I think that's evidence enough that it's really just a typo in the documentation if it's not, because, oh, it is able to be accepted. Okay, well, let's see if it shows up in the routing table now. Pipe refresh one, everyone, see if it takes a while. I don't see it taking a while, so. And the other thing is, I don't even know where there's a .20 configured anywhere. There's no .20. There's a .2 right here. So maybe they just meant .2. That's something I can try as well. So edit. So I can just up arrow to where it was. Show pipe display set relative. And now I can try that as a .0. I mean, that might make sense because if we're advertising out to our neighbor, then, okay, so this actually could make sense because I'm thinking of it as, okay, so this is just something for me, but really, if this is meant to be re-advertised out to another neighbor, this is only going to make sense if you think of it from the vantage point of that other neighbor. So if we do that, and let's just pretend that we're on router B, where this is going to get advertised out to, and we were to go on router B, and we were to configure this routing address, or sorry, this static route, now this is going to kind of make sense because, well, assuming that you, of course, use the host address and you, of course, specify a next hop that is configured on router C, because, okay, I'm going to learn this from router C, and now it tells me how to get to this special .16 that's not going to be in my table, run show route. I'm only going to have the first subnet in those stack of subnets, but I need to know how to get to the third one, and it's going to tell me, oh, well, you can use C. So C can send a message over to B saying, if you want to get to this route, just come to me. So that's kind of a nifty thing you can do, actually, is instead of having to go to a router and configure a static route on that router, you can go to a different router, configure the static route on that router, and then re-advertise it over as if you had configured it on that first router. So that's kind of a nifty thing if that's the way this works, and we'll see if that's the case. And I'd like to take another look at the help menu for re-advertise. So set re-advertise, mark as eligible to be re-advertised. Okay, so again, you're getting a very small explanation, but one thing you can do is just go to Google, Juniper, BGP, re-advertise. And here you go, you've got documentation on that knob. And it'll give you more information. So configure whether static routes are eligible to be re-advertised by routing protocols. So if you didn't have this knob configured, you could not go ahead and add it to a policy option. And one thing that might be interesting, I don't get why it's doing protocol policy. Okay, so edit policy statement, export static from. Now let's see what kind of protocols there are to choose from, because to me it seems, yeah, it seems like you would want to do static, not BGP, because it's a static address. So why would you put BGP there? Oh, okay, well that's something we're going to try. If it doesn't show up in this routing table, we're gonna make a change there, and we're gonna see if it causes it to show up. So show route protocol, we've got nothing in there right now, but let's go ahead and take a look at what we were doing before. So let's take a look at the last commit. So we changed this over to be a valid next hop, and we're kind of going to go with the assumption now that the purpose of this exercise is to show that you can actually send a static route to another router, and instead of actually having to log into that router and configure a static route on it to accept the static route, as long as you have a valid BGP connection, you can just configure it remotely and have it pick it up based on the configuration you did on a different router, which is actually kind of an exciting new concept for me that I actually did not know you could do. So definitely going to want to get that working. And I think a way to do it is to, instead of using BGP protocol to export, we're going to export static into BGP, because of course we are. But you can see here, so we're going to export, and it even says here, export.static, that's the naming. So this is definitely worth another downvote. So this is like 3 downvotes, but I mean, when it has this many issues, it just requires this many downvotes, unfortunately. So we're going to copy this, make it nice and easy for them to identify the part in the documentation where there's an issue, and then give them a nice and clear explanation as to why there's an issue and how they can potentially fix it. So why is the protocol in the statement from protocol, why is BGP the protocol in the statement from protocol BGP? Wouldn't the protocol need to be static? Okay, so I think this is pretty good. I'm going to submit that. And we're going to keep going. We're going to see if that works. So let's see here. So, okay, so we're going to edit this export-static, which is exporting BGP and not static. So we're going to make it export static. And then we're going to hopefully have that route pop into that table. And sure enough, the concept of it being able to have a static route configured on it by way of another router configuring it and then exporting it into BGP will be a valid concept, assuming that works. So let's see if it works. protocol static. So there was also another knob where BGP static. So this is interesting because I wonder if that's a BGP static route or just a static route. But if this doesn't work, we can of course go and try that other one, and maybe that will cause it to work. So still nothing, unfortunately. I think it's a good time to go and try that other one, see if that works. So let's try the other one. Delete protocol static. Set protocol BGP static. And hopefully this works. Another thing we can do is refresh that neighbor adjacency. This is not something you would do in prod. So clear, and then what do we got here? BGP, yep. And then neighbor. We'll just clear them all, we've only got one. So it's inactive, hopefully we'll build that soon, and we'll see if it sends that route over. If it does not, we can go back to that static one, because I kind of think that's more likely to be the correct one. So it looks like it's still inactive. Kind of surprised that it's not able to go back. Just takes a while. Here we go. So now it's established. So still nothing. Let's go ahead and try that other one. So it keeps your buffer even when you leave and re-enter configuration mode, which is nice. So let's set this back up to just regular old static. And clear that neighbor, and hopefully it will start to learn it. So as we saw before, it takes quite a while for it to reestablish that. It might even take long enough so that I can start a capture right now, and we'll have plenty of time to watch it. Yep, it looks like it's still going. So if this capture will come up soon, might be even be able to get it on the capture. Still inactive. Here we go. So there's our first connect. Now we got our open sent. So then we got our open confirm. And now we've got our established, which doesn't list up there, but here's our open messages. You can see different source and destinations. So here's the first packet that's initiating this neighborship. Let's take a look in there. So this is router B, actually. It looks like it's kind of not what I would have expected. I would have expected the first one to come from router C, because that's where I cleared it off, but it looks like it came from router B first. Got some optional, so this is MP BGP. It's kind of interesting because I thought MP BGP you would need some special configuration. which really don't have. I just have a basic BGP config. But let's take a look at the next one. Maybe there's some differences. Looks like there aren't any differences really. So yeah, that's interesting. Route refresh capability Cisco, that's interesting. Okay, so unfortunately, we're not able to get that route to show up. But that's something we can definitely work on. And just think about how, another thing we can do is we can do show route advertising protocol BGP. And then we have to specify the neighbor, but we've only got one neighbor, so that's really easy. And just do a detail right away. So sure enough, we're not advertising any routes out through BGP right now, so that's going to be an issue. Those are some really great commands. So that last exercise with the options A, B, and C was very helpful. If nothing else, just to get more comfortable with those commands is kind of the main goal of these videos, is just to get really used to diagnostic troubleshooting commands that'll help me during the test. So already goal accomplished with learning those two. And we can see from protocol static. So let's take a look at the static. Oops. Show route protocol static. So it looks like we actually don't have any static routes. What about this route though? I'm surprised that we don't have this static route. Because that definitely, maybe because the next hop is invalid. Let's see what happens if I put a valid next hop from the vantage point of router C. Because there definitely is a valid next hop from the vantage point of router B. So if we assume that the intent of this exercise is to configure a static route on router B by configuring it on router C and then re-advertising it through BGP so that it's actually used by router B, that would be accurate, but I really don't think that's how it works. Especially since if you're able to route a route, why would you need a route? That's the purpose of a route, is to allow for a situation where you can exchange. Well, I mean, you could have this destination be anything, so that could be a reason. But it just doesn't seem like a feature that would be like all that useful. Like you'd probably have management access to this, like maybe like a recovery situation. If you couldn't get into this and you knew that BGP was up, you could send over your management subnets, new management subnets, something like that. But let's just see if we can get this working. Oh, and it's going to be routing options, not protocols. Edit routing options, static route. Whoops. So here it is, and that's the next hop. So let's delete that. All right, and now let's set a next hop that's going to be valid from the vantage point of router C. So that's just going to be .1. All right, now let's take a look at the routing tables. Yep, so now that this is a valid statement from the vantage point of router C, we see it showing up in the INET 0 route as a static route, and it's got a low, so this is the administrative distance in Cisco speak. I don't remember exactly what it's called in Juniper speak, but this is what determines which route is used if there are multiple routes, and if they're across different protocols. So if you have a OSPF route, a BGP route, and a static route, it's going to use the static route because this number is going to be the lowest. Within protocols, you're going to use a metric value. But let's go ahead and see if this is now being advertised over, now that it's a valid route. Looks like it is not. So let's take a look at the configuration. Okay, so let's try changing this here. And we'll try BGP static first, and then we'll try just regular BGP as is in the exercise. All right, and before I clear that off, I'll just see if it went through. It did not, so I'll clear it off. And we can check the Wireshark capture to see this relationship, BGP neighborship, establish. So we're probably going to, and I'll just filter it out by TCP now. I might get some more traffic that we didn't before just by filtering out for BGP. We should see a four-way handshake. Sorry, a three-way handshake, and then we'll see a four-way disconnect when I do that clear. But for it to establish the neighborship, we'll see the three-way handshake. So it's going to be a SYN, SYNAC, ACK, and I'll show you that. So we've got in the flags here. So, well, no, actually, no, I'm looking in the packet header. So I'm looking at layer 3. We're going to need to look at layer 4 in the segment header. So looks like I need to update my malware. Don't send me malware now because my malware is not updated. But let's, oh yeah, so it looks like it's just not opening the right one. Okay, here we go. So here's the SYNAC. So let's go and look here. So now we got a SYN from .2. So .1 will respond with, so it looks like they're both trying to do this. So let's just see from which side it's established from, because they're both going to attempt to establish it. It's only going to be established from one side. You're not going to have two sides as far as I understand. So, so it looks like the winner is .1. .1 sends the SYN, So even though .2 sent the SYN, .1 wasn't ready to get the SYN ACK yet, so it went ahead and sent a SYN out itself because it never received the SYN from .2, so it didn't know to respond with a SYN ACK, and it was like .2 was trying to establish that BGP neighborship, so it went ahead and sent out a SYN. But .2, of course, was already up and ready to go. We can see here because it was sending out SYNs before, so it says, oh, okay, well, I said hello to you. You didn't say, I said good morning to you. You didn't say good morning, sir, back to me, but you did say good morning to me. So I know you didn't hear me say good morning to you, but it would be rude for me not to say good morning, sir, back to you because you did not blow me off and give me the cold shoulder. You actually did say hello. So here's the SYN. Here's the SYN ACK response from .2. And now here's the, oh, it looks like it is, it's interesting because I thought that you would just get, an ACK here, but it looks like you're getting another SYN ACK. So I'm not sure why there's another SYN ACK. So here's what I was expecting to see, the ACK. So I was expecting to see a SYN from .1, a SYN ACK from .2, and then a ACK from .1. But it looks like I'm getting an ACK from .2 and a SYN ACK from .1. So I'm getting a SYN, SYN ACK, SYN ACK, ACK. So .1 sending a SYN, .2 sending a SYN ACK, .1 is now sending a SYN ACK, and .2 is now sending an ACK, which is not what I would have expected. If we go to Google and we look up the TCP three-way handshake, you can see the process between the client and the server is going to be SYN, SYN ACK, ACK. So it's really quite unexpected to see it be SYN, SYN ACK, SYN ACK, ACK. It's probably just jumbled up. So it really is a SYN, SYN ACK, ACK. It's just out of order. And we can see the order actually here of the packets. I mean, they're going to be listed in order. Another thing we can do is filter it. So based on this first SYN, well, let's do the very first packet up here. So we're going to do follow TCP stream. And now we can see, sure enough, this makes more sense. And we've got a SYN. Now we've got a SYN ACK. And now we've got an ACK. So now we can see just how much more sense that makes when it's filtered out appropriately and you don't have unrelated TCP conversations overlapping each other. That's why it's so important in Wireshark to know how to use the filter, know how to follow the particular stream, because otherwise it can look like, oh, I've got a SYN, SYN ACK, SYN ACK, ACK. That doesn't make any sense. Well, it's because you're listening to two conversations at the same time, and if you filter it out and you see, yes, it's SYN, yes, it's SYN ACK, yes, it's ACK. Now you know you're following one conversation, and we can see more clearly now what happens is after that three-way handshake is established. And the other thing to note is it does appear as though this is a process that occurs in both directions. You have so if I clear this out and I go for BGP again, and I now follow the stream here, now instead of a SYN, SYN ACK, ACK going from .2, .1, .2, I've got a SYN, SYN ACK, ACK from .1, .2, .1. So we've got BGP neighborships happening on both sides. It's not like you can use it's not like when .1 forms a BGP neighborship to .2, that .2 now automatically has one to .1. No, they both need to form their own relationships. So they both need to use their own SYN-ACK three-way TCP handshakes in order to figure that out. And you can tell, one way you can tell which was the source and which is the destination. So if I didn't have, let me see how I can pose this as a question, but well, I guess without posing it as a question, one thing I'll just note, and here you can see really clear SYN-ACK. So these are the ports, and you can see the destination port here is 179, the port for BGP, and the source port is ephemeral. So you know that this was sourced from 198.1 to .2. So you know where this was sourced from because it's going to be sent from the device that opens up ephemeral port. And you can see there's going to be an ephemeral. So ephemeral, if anyone, I mean, you can look it up, but it's just a random port in a specific range. And BGP has its own specific port, which is 179. But if I go back and look at the other one, so this is .2, .1 to .2, you can see same thing, but it's a different ephemeral port. So both of these devices are going to have ephemeral ports open, and they're going to have the ports to BGP open. But the thing is, their ephemeral port is going to be for a connection to their neighbor, but their port BGP is going to be for the connection that their neighbor established to them. So that's kind of a good thing to know, and something I actually didn't know before this video, is that you're going to need two separate BGP connections to establish one BGP neighborship. You're going to need one that originates on router A. Say you just have a topology of router A and router B. You're going to need a BGP TCP three-way handshake between router A and router B, where A does SYN, B does SYN-ACK, and A does ACK, and A opens up an ephemeral port, and B opens up the specific 179 BGP port. And you're also going to need the opposite of that, where B sends out the SYN, A sends out the SYN-ACK, and B sends out the ACK, and B opens up the ephemeral port, A opens up the specific port for BGP 179. You need both of those to happen in order to have one BGP connection. So, and then you can see immediately after the three-way handshake, we've got that open message. So we're establishing BGP now. And now we've got, looks like this interesting TCP retransmission. I'm not really sure what this one is. And we got another open message. So it looks like this one has the, okay, so that's interesting. We've got one open message for each of the routers. And now we've just got a regular old keep alives. But yeah, that's good to know. So a lot of good information there about how BGP will establish a neighborship. Another really good command to know on any piece of networking equipment you're on. And I don't even know what this command is on Juniper, but I think I can figure it out. So you can actually look at which ports are open on the device, and that can really help you understand the kind of traffic that is being sent to it. So most traffic is just going to move straight through your device, so they're really not going to have ports open. They're just going to be processed in the MAC address table or the ARP table or the routing table But for management traffic, including BGP neighborships, OSPF neighborships, SSH sessions, it's going to have to open up a port. So connections looks unrelated. Looks like it's circuit cross-connect connections. So that's for more layer 2 VPN stuff. But it's probably under system. And then I would bet that it's going to be maybe processes. That looks promising. Or maybe information. It could be show system connections. That could be it too. Yep, that looks like it. So yep, this is it. So show system connections is the command I was looking for. And we can see, here's our BGP connections right here with our ephemeral ports and our foreign address with the port for BGP, instance state established. So, and then you can see there aren't any other, there are some other connections, but these are probably just internal connections or something to do with it being emulated. But if I had a SSH session to this, which SSH isn't set up right now, but I'd match G dash. So yeah, I don't have SSH set up to it. I wonder if I could set up telnets is enabled by default. Nope. But anyway, you would see those pop up here. And then of course you'd have a ephemeral, depending on where it's sourced from, that would have the ephemeral, and then to where it's being sent, that would have the port 22. So let's keep going with the exercise. Video is probably getting long by now, and I need to switch my laundry over to the dryer. So router B, show Bgp summary. Looks good. Router C, show Bgp neighbor. Yep, we're doing the export static again, and we played around with the configuration there. Looks like we've got BGP static now. Let's switch that over to BGP just because that's what the documentation says, even though we downvoted it and kind of questioned why it said that. So now let's delete protocol BGP static and set protocol BGP. And hopefully this command here, show route protocol BGP, will now be more like what we were expecting. You can try restarting, setting that neighbor. So yeah, I'm not really expecting that to work. I really don't understand kind of what this lab is getting at, and I really don't understand the static route statement, and I would actually really question that that is accurate information and it's not just a typo, especially since they're listing a host address in a routing table. You got to have routing addresses in your routing table. Or you've got to have network addresses in your routing table. So let's just keep moving. And unfortunately, there are some labs where you've just kind of got to take a different learning experience with you than the one that was offered to you initially. And I think with kind of learning more about how BGP neighborships are formed, I think that's a great learning experience. So even though it's not the learning experience that was intended through this lab, I can mark it complete and move on, and hopefully be prepared for the tests through that way. So yep, I think that's what I am going to do. It looks like this lab is finished. Fortunately, I wasn't able to take with me the learning experience that this lab had planned for me, and that was to take a look at the re-advertise knob and kind of figure out what that does, and see how you can put a static route into another router's routing table just by re-advertising it through BGP. So unfortunately, that does not seem like something that is possible to do the way it is described here. But I took different learning lessons that I think will be really useful to the exam, how to kind of what to expect from a BGP neighborship more, how to filter out Wireshark better and see that three-way handshake form, and kind of what kinds of messages to expect during that, the BGP open messages. So I think this was pretty useful, but I'm going to go ahead and mark this off as done, even though I didn't make it through. And we're going to go back here. And this topic, I'm going to rename and say that the labs are done on this topic. And I'll be moving on to the next topic, which is authentication. So thanks for watching, and I'll see you in the next topic.